Hi guys, I'm Joshua and today we'll be going through IDA Pro, and in this example we will be using a malware.exe which has been unpacked, and the unpacker we use would be was aspect.die, which is, and also now we'll open up IDA Pro and open up the unpack.exe into the IDA Pro. In the start function, basically the first thing we'll be doing will be viewing the X reference chart, and this chart basically shows the major subroutines of the start function. And in order to do so, we'll need to make some changes to the code by changing the recursion depth to from -1 to 1. And as you can see now, we are able to see the major subroutines of the start function. However, there are too many of the subroutines which will be very difficult for us to cover everything. So basically we will not be covering everything. We will only be covering the important ones and the first few functions, and a few of the important functions which make the malware what it is. However, before that, we'll be going into the graph view to see the flow of the program. And as you can see, there are several subroutines, and each subroutine are calling other subroutines to work together as a function. I'll be going through the first few subroutines, and then we will be going ahead into the main functions which define the malware. And as you can see, we have reached the end of the graph, and let's go ahead and get into the first subroutine, which is the start routine. Basically, it pushes a variable into the stack and declares ECX to be 5. This causes the function to be reloaded with ECX, which decrement by 1 each time. The next subroutine gathers the variable inputs and loop for 5 times before it jumps to the next subroutine, which creates the mutex file, and followed by checking if there was an error with the creation of the mutex file, which indicates that the infected computer has already been infected by a previous infection. The next subroutine gathers the variables needed and call on the function from window exa. The subroutine then compares a few variables, and if the results return as expected, the program moves on to the next subroutine, or else it calls on post message A, which is displayed in the window specified earlier. Now we'll go ahead and go into the import section, and as you can see, we are able to see several imports like get keyname text A, get key state, get keyboard layout, get keyboard layout list, get keyboard state, get keyboard type. And these are some keyboard functions that we have found throughout the imports, and however there are also others, and these are the functions which are inside these are the subroutines and or functions which is inside the IDE view. As you can see, each function takes in a separate argument in order to function. Another two function that we would like to take note of would be map virtual key A and load keyboard layout A. These are also important functions that make the malware what it is, which is a keylogger. Basically, a keylogger captures keystrokes of a user, and yeah, we'll be looking at some of the codes which make the malware a keylogger. These are basically some of the few functions which are suspicious. So basically we'll be performing a keyword search on the keyword key. And as you can see, after the keyword search, it returns a occurrence of 670 lines. However, we will not be covering everything, and we'll be looking into a few of the lines which are more concerning. One of the functions that we'll be looking at will be subroutine 438FA0, and basically it translates the virtual key code into a scan code or character value, or vice versa, and retrieves the name of the key in text. In this analysis, we analyze that this malware might be using this function to get the keystrokes of the name of a key that has been pressed by the user, or in other words, keylogging. The next subroutine we'll be looking at will be 446D64, and basically this function gets the keyboard layout and retrieves the handle to the device context and device specific information and release this information for use by other applications. This subroutine is probably used to identify the input device the victim uses and also the keyboard layout, so that it will be able to get the keys that are pressed and release the information about it, so that the malware can proceed to get the keys entered. And as you can see, this subroutine calls on many various subroutines, and these subroutines also help this malware to function. And this is the end of the IDA Pro video. Thank you.